5.2 is polynomials, linear factors, and zeros. The first type of example we're going to talk about is writing polynomials in factored form. So for these polynomials, we're going to factor them just like any other factored problem. So we start off with this problem. It's x to the third problem minus 2x squared minus 15x. We're going to look to see if it has a greatest common factor. So notice an x goes into all three of those terms. No number goes into all three, so we can just factor out an x. So we bring out an x. If we divide each of these by x or take an x away from each of them, then we have x squared minus 2x minus 15 left over. If you want to distribute to check to see if you have what we originally started with, that would be a good way to check your work. And then this part inside parentheses, we're going to see if it factors further. So we're going to take our a times our c, so 1 times negative 15. We need to come up with all the combinations that multiply to negative 15 but adds up to negative 2. So we have 1 and 15, 3 and 5. The only combination that would work to add up to negative 2 would be a negative 5 and a positive 3. So we throw that in as our last terms, a negative 5 and a positive 3. The order does not matter. And then make sure you bring this x that we factored out down. It's still part of the problem. If you drop it, we get rid of it, then if we FOIL this out, we wouldn't get what we started with. Okay, so we still need to keep that x. So that would be our factored form. Let's try another problem. So we have x to the third power minus x squared minus 12x. And x goes into all three of these terms again also, so we factor that out. And then what we have left over is x squared minus x, or minus 1x, minus 12. And then from here we take our a times our c, we get negative 12. So we need to come up with what multiplies to negative 12, but adds up to the middle term, negative 1. So we have 1 and 12, we have 2 and 6, or we have 3 and 4. And the only combination that works to get to negative 1 is the negative 4 and a positive 3. So we throw that in. Again, the order doesn't matter. And whatever we factor out, we still keep that as part of the original problem, or the answer. Now, from here, what they're going to ask us is, or why we need to know how to factor, they're going to give us an equation and they want to know what are the zeros. So if they give us this equation, and this one they were nice, they already gave it to us in factored form. So if it's in factored form and they want to know what are the zeros, then each of these factors, we're just going to set them equal to 0 and solve for them. So this x plus 2, we set this equal to 0. We solve for it, so minus 2, we get x equals negative 2. This next one, x minus 1, we set that equal to 0. We solve for it, so plus 1, we get x equals 1. And x minus 3, we set that equal to 0. We solve for it, so plus 3, we get x equals 3. Now notice, in terms of the graph, if you would graph this equation, you can graph it just like this in factored form, or you could FOIL it out into standard form. You're going to get the exact same graph, and these zeros are where it crosses the x-axis. So if you got to a problem and you couldn't factor, or you don't know how to factor it, just graph it and see where does it cross the x-axis, and don't label it as coordinates, just label it as the x values of those points. So this one crosses at 3 different places, so then those are zeros. Do not label where it crosses the y-axis. When it says what are the zeros, they're looking for where does it cross the x-axis. So let's try another one. We have y equals x times x minus 3 times x plus 5. Now notice this one has an x factored out, so we still need to set that equal to 0. So we'd have x equals 0, x minus 3 equals 0, and x plus 5 equals 0. Now this first one's already solved for us, so that was nice for us. This next one is we add 3, so we get x equals 3, subtract 5, and we get x equals negative 5. Now if we look at the graph, it's going to cross at negative 5, it's going to cross at 0, and it's going to cross at 3. Now notice, for this one, if we would put this in standard form, notice our leading terms, we have an x and then an x and an x. X times x times x would give us x to the third power. So that's why we get this overall shape, that it has the two curves. The arrows are going opposite direction, and it's positive, so from left to right it's increasing. Now this next one, we're working our way backwards. So we now want to write a polynomial function. So we want the equation, and they're going to give us our zeros. So they're telling us our zeros are negative 2, 2, and 3. So if we look back at these first two examples that it said, what are the zeros? Notice if it was negative 2, back in factored form, it's positive 2. If our 0 is 1, and back in factored form, it's negative 1. If it's 3, then back in factored form, it's negative 3. It's always the opposite, because I think if we set it equal to 0, so we solve for it, we're going to get that opposite. So if negative 2, 2, and 3 are zeros, we're just plugging in the opposite. So we'd have x plus 2, x minus 2, and then x minus 3. We just plug in each of the opposites. Now there's 3 zeros, so we should have 3 different factors. You can leave this in factored form, or if they say please put it in standard form, then you're going to need to FOIL it out. So to FOIL it out, you do 2 at a time. So these first two, I'd go ahead, they're opposites. So I'd go ahead and multiply those first, because our middle terms then are going to cancel out. So x times x, we get x squared. X times negative 2 is negative 2x. Distribute then all this 2, so 2 times x is 2x. 2 times negative 2 is negative 4. And then we just bring this last one down. Now this negative 2 and positive 2, they're just opposites, so they cancel out. So then let's keep simplifying it. We get x squared minus 4, and then we bring down this x minus 3. Now we FOIL again. So we distribute this x squared. X squared times x is x to the third. X squared times negative 3 is negative 3x squared. Distribute this negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12. And that would be standard form. So please read the directions. If it just says write a polynomial function, either of these answers would be perfectly fine. If they say leave it in factored form, then I want this answer. If they say put it in standard form, then I would like this answer. Okay, and a good way or a quick way to check your answer on this one, if it was like an assessment, that just go ahead and graph this on your graphing calculator or Desmos, and then see if these 3 solutions are where it crosses the x-axis. Alrighty, now this next one, the zeros are negative 2, negative 2, 2, and 3. So we're going to plug in the opposites. So we have 4 different zeros, so 4 different sets of parentheses. We plug in the opposites, so x plus 2, x minus 2, and x minus 3. And then from here, this would be our answer if they wanted factored form. If they want it in standard form, we got to go ahead and distribute or FOIL. So we're going to do the first 2 together, then we're going to do the last 2 together. So if we do the first 2 together, we get x. We're going to distribute, so x times x is x squared, x times 2 is 2x. Now distribute the 2. 2 times x is 2x, 2 times 2 is 4. Okay, I would combine our like terms, so x squared we bring down, and then 2x plus 2x is 4x, and then bring down this 4. For our next one, we're going to go through, sorry, my camera's getting off. Keeps moving on me. So for these last 2, x times x is x squared, x times negative 3 is negative 3x. Then we distribute the negative 2, so negative 2 times x, negative 2x, negative 2 times negative 3 is positive 6. Combine our 2 middle terms, so negative 3x minus 2x is negative 5x. They're like terms, so we can combine them. Then we FOIL again. So then we're going to distribute this x squared to all 3 terms. So x squared times x squared, x to the 4th. X squared times negative 5x is negative 5x cubed. X squared times 6, 6x squared. Now distribute this 4x to all 3 terms. So 4x times x squared is 4x cubed. 4x times negative 5x is negative 20x squared. 4x times 6 is 24x. Lastly, we're going to distribute this 4. So 4 times x squared is 4x squared. 4 times negative 5x is negative 20x. And 4 times 6 is 24. Now our last step that we need to do is just combine our like terms. We want to put it in standard form, so our exponent's highest to lowest. So we have this x to the 4th that we're just going to bring it down. And then negative 5x cubed plus 4x cubed, we get negative 1x cubed. 6x squared minus 20x squared plus 4x squared gives us negative 10x squared. And then we have 24x minus 20x is 4x. And lastly, this 24 has no like term, so we just bring it down. So that would be our standard form. Again, look at the directions, see what form. It could save you a lot of time. If they just want it in factored form, or they just say write a polynomial function, then this first answer would be perfectly fine. But if they do say put it in standard form, you need to do these additional steps. Now the next type of example is saying find the multiplicities of the zeros. So we're going to take an additional step. Now this one is not factored, so we want to factor it first. So notice they each have two x's in common, so we're going to factor out an x squared and then divide each of these by x squared, or take two x's out of each of these terms. So then if we do that, we have x squared minus 2x minus 8 left over. And if we distribute, we should get what we originally started with. And then this part inside parentheses should factor further. So we need to take 1 times our negative 8. We get negative 8. We need to see what multiplies to negative 8 but adds up to our middle term, negative 2. So we have 1 and 8, 2 and 4. So the only combination that would work is this 2 and 4. The 4 would have to be negative and the 2 would have to be positive. So we throw that in as our last terms, and this would be our factored form. Now from here we would need to find the zeros first. So again, we set each of these equal to 0. We solve for them. So we get x squared equals 0, x minus 4 equals 0, and x plus 2 equals 0. We solve and we get x equals 0. If we take the square root of both sides to undo that squared, we get x equals 0 because the square and the square root cancel out. We add 4, we get x equals 4. Then minus 2, we get x equals negative 2. So those would be our zeros. And then how we find the multiplicities, how often they occur, we need to, we'll get the exponents. So this one is to the second degree, so the multiplicity is 2. This one didn't have an exponent, if you look back in factored form, so the multiplicity is just 1. This one didn't have an exponent, so the multiplicity again is 1. You're never going to have a multiplicity of 0 because that's just saying that term does not exist. Alright, so if we take a look at this one, we have x cubed minus 4x squared plus 4x. So each of them have an x in common. There's no number that they have in common, so we can just factor out an x. Then we have x squared minus 4x plus 4 left over. Then we take our 1 times our 4. We need to see what multiplies to 4 but adds up to negative 2. So we're going to have to do negative 2 and negative 2. That adds up to negative 4, but it multiplies to positive 4. So we throw that in. And then we can rewrite this because x minus 2 and x minus 2, so just x minus 2 squared. And then we set them equal to 0 to find our zeros. So x equals 0 and x minus 2 equals 0. And then we go ahead and solve them. So we get x equals 0 here, and then we get x equals 2 here. This x equals 0 didn't have an exponent, so it has a multiplicity of 1. This x minus 2 had an exponent of 2, so the multiplicity is 2. Now if you graph these original equations, you're going to notice the multiplicity of 2 is just going to show you that at that point there's a turning point. So it's still going to cross the x-axis at those points, but is there a turning point there or not is what these multiplicities are telling us. So take a look at the graph so you can see the difference. Now our last topic that we're going to cover in this section is relative maximum and minimum. And not that it's difficult, but that word relative out in front, I don't want it to throw you off. So when we take a look at the graphs of y equals x cubed plus 3x squared minus 24x, then it looks like this. Now relative maximum and relative minimum, if you look at this graph, what that means is just in terms of the curves, where's the maximum and minimum value? Okay, and so don't look at the arrows because it just said find the maximum and minimum, it's going to be a positive infinity and negative infinity. But that word relative means in terms of the curves, what is the maximum value, what is the minimum value? So this is our highest point, so we're going to label as our maximum value. So we label it as a coordinate. This is our lowest point, so that's our minimum value, so we label it as a coordinate. Now this second one, we have y equals 3x cubed plus x squared minus 5x. So we do the same thing, that we graph it, it looks like this. And then to find this point and this point, that's going to be our maximum and minimum. Now, if you're struggling with graphing it, let me get my graphing calculator so I can help you with that part. So we go to our y equals to graph it, and then 3x to the third power, so caret 3, plus x squared minus 5x. And then we click graph. We get this graph, and then we need to see what this highest point is and what this lowest point is. So what we're going to do is second trace, and we want to find what our minimum and maximum is. So if we want to find our maximum first, let's go to that. And our maximum is over here, so we need to go to the left of it and then to the right of it. So we're going to left arrow over, just go to the left of that maximum point, and then right arrow over to the right side of that maximum point, and it can be high or lower. Just go to the right of that point. Click enter again, click enter, and then it gives you that coordinate. So you just write that down, and notice I rounded to the tenths place, so 1 decimal, you can do the same. And then if we go to second trace, we go to minimum. So then we need to find this point down here, so we go to the left of it, click enter, we go to the right of it, click enter again, and then it gives us the coordinate. Again, I rounded to the tenths place, 1 decimal. You can do the same.